I welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology, Kanyakumari. In this video, we will see about the Anna University third semester paper. Now, after the completion of this video, student will be able to convert the state variable models to transfer function model. So after this completion of this video, student will be able to convert the state variable model to transfer function. Now we will see about the conversion of state variable models to transfer function models. Already in previous video, I explained state model of linear system consisting of a two equation. One is a state equation, another one is a output equation. So state and output equation is a function of a state variable and input variable. So the state model of a system consisting of state equation and output equation. So that is a x dot of t is equal to a into x of t plus b into u of t. This is a state equation, and output equation be y of t is equal to c of x of t plus d into u of t. This is the output equation. Now taking a Laplace transform with zero initial condition in the state equation as well as the output equation. So the equation can be changed as s into x of s equal to a into x of s plus b into u of s. This is the state equation when we taking a Laplace transform. And similarly, output equation is a y of s is equal to c into x of s plus d into u of s. So now the state equation can be placed in the form of, we want to simplify this state equation after the Laplace transformation. So si minus a into x of s equal to b into u of s. We take a x of s a common term in the previous equation. So the state equation can be placed in the form of s into I minus a into x of s equal to b into u of. Now pre-multiply both sides by si minus a inverse. We will get that is a x of s is equal to si minus a inverse b into u of s. So now substitute the x of s in the output equation. So we have a x of s equation, that is a si minus a inverse b into u of f. If this equation is substituted in the output equation, we will get that is a y of s is equal to c into si minus a inverse into b plus d into u of s. So the transfer function matrix is as t of s is equal to y of s divided by u of s. Y of s divided by u of s is equal to c into si minus a inverse b plus d. This is a transfer function of the matrix. That is, we convert that is a state variable model to transfer function model. Now we will see about the one example to convert state variable model to transfer function model. Let us see the one example. So state space model is given by x1 dot and x2 dot with the matrix format 0 1 minus 2 minus 3 into x1 x2 plus 0 1 u y is equal to, that is a state equation. Next one is the output equation, y is equal to 1 0 x1 x2 plus 0 into u. So this is a state equation and this is the output equation. We need to find the transfer function of the system. So they are given a state space model and equation. State space model equation is consisting of a two equation. One is a state equation, another one is a output equation. They are given the state equation as well as the output equation. Now we need to convert this state space model to a transfer function of the system. Solution. So now let's compare this our given state space model to our standard state space model equation. This is a given data. This is a state space model equation. This is a state equation. And this is the output equation. Now compare with two equation with our standard state space model equation. We know that the formula x dot of t is equal to a into x of t plus b into u of t. This is a state equation, and also output equation y of t is equal to c into x of t plus b into u of t. This is the output equation. Let us consider compare these two models. State equation compare with the x1 dot this matrix, and similarly output equation is compared with this output equation y is equal to 1 0 x1 x2 plus u of 0 of u. So when we compare the two equation, we will get there is a matrix value, b matrix value, c matrix value, and d matrix value. So hence a is equal to 0 1 minus 2 minus 3 matrix, b is equal to 0 1. This is a this is a and next c is a 1 0, this is a d. So when compare the two equation, we get, so we compare the two equation, so we get there is a value, b value, c value, and d value. Now we studied there is a conversion of state variable model to transfer function model. So t of s is equal to c into si minus a inverse into b plus d. So substitute all the values of a, b, c, d in this equation. We will get the transfer function of this system. So when we substitute that value, so C value is a 1 matrix of 1 0, and S value Si value is a S into S 0 0 S, minus A value is a 0 1 minus 2 minus 3 inverse, and B value is a 0 1, and next D value is a 0. When we simplify this equation, we will get that is a transfer function. So transfer function T of S is equal to 1 divided by S square plus 3S plus 2. This is the answer of this problem. So now we convert the state space model to our transfer function model. So now we will see about the one problem. This problem: obtain the transfer function model for the following state space system: A 1 1 minus 6 minus 5 matrix, B 1 0, C 1 0, D 0. They are given a state space model, and we need to obtain a transfer function model. So we know that the conversion of a state space model to a transfer function model formula, that is a T of S is equal to C into Si minus A inverse B plus D. This is the formula for to convert a state space model to a transfer function model. When we apply this value to this formula, we will get that is a T of S value is a 6 divided by S square plus 5S. I hope that you are all understood about the conversion of state variable model to transfer function model. Thank you.